Let's evaluate this line integral to find the mass of a coil. The mass is equal to the line integral, where c is the path or the coil, and rho of x, y, z is the density at a given point, and ds. Now recall that ds is equal to the magnitude of the r prime of t dt. So let's come up with first the basic line integral formula and then work through rewriting it as a definite integral. So the mass is going to be evaluated this line integral where our density function in this case is defined as k plus z ds. Now the coil is given by the vector valued function r of t equals 2 cosine ti plus 2 sine tj plus 3tk. If we take the time to trace out this path, you would have to sketch it in 3 dimensions. If you let t equal 0, the location of this path is at the point on the x-axis where x is equal to 2. If you continue to increase your time, the coil is going to spiral up around the z-axis. In fact, when t is equal to pi over 2, the location of the coil is 0 units in the x direction, 2 units in the y direction, and up 3 pi over 2. And at t equals pi, the location is negative 2, 0, and 3 pi. It's going to continue to increase. So the coil is going to look something like this as it moves up. And we want to look at the mass of the coil from this start time t equals 0 to this end time up here t equals 2 pi. So we want to replace any x, y, and z in the integral with what it equals on the path, and we want to replace ds with the magnitude of the r prime of t dt vector. So if we know that r of t is given here, we want to find r prime of t. R prime of t is equal to the derivative of each of the components. The derivative of 2 cosine t is negative 2 sine t. It's going to be your I. The derivative of 2 sine t is 2 cosine t, j. And then the derivative of 3t is 3. That's going to be your k. So we want to take the magnitude of this r prime of t is found by taking the square root of each of these components squared. So negative 2 sine t squared plus 2 cosine t quantity squared plus 3 squared. And when you simplify this, you get 4 sine squared t plus 4 cosine squared t plus 9. And this will simplify because 4 sine squared t plus 4 cosine squared t simplifies to 4. This will simplify to the square root of 4 plus 9, and when you simplify that, you get the square root of 13. Alright, so now we can rewrite our line integral for mass. It's going to be written as a definite integral from the start time to the end time of 0 to 2 pi of k. K is going to be a constant. We see that a lot in our density formulas. We'll leave that alone, but we are going to replace the z in the line integral with what z equals on the path, and z equals 3t on the path. And then we're going to replace ds with the magnitude of r prime of t, so that's going to be our square root of 13 dt. So now we have a single definite integral. Our variables t, we do have a constant in there. You can work this out and you'll find that the answer to the mass is going to be the square root of 13. You can bring that out in front times that what you get when you evaluate this definite integral, and that's going to be 2 pi k plus 6 pi squared. So that would be the mass of the coil for the time interval from 0 to 2 pi.